Hi there. First off, I should say that in this video, I'm not gonna start teaching statics from the beginning, and I just want to mention some points I'm sure you'll be interested in. Okay, in the middle of your course, you see problems like this. Here's the structure with a given force P applying on it, and the problem requires you to find the force applying on a member like this, the red one. Also to determine whether the member is in tension or compression. But why? Why we should know, or we need to know, the value of the force applying on such a member, also whether it is in tension or compression. Here I'd like to talk about it, but before that I should say such a structure is not in the nature as a tree or a rock, and it is made by man. But why they designed it like this, with these members, with the members with these lengths and angles. Actually, this is from the other courses, which I'm not gonna talk about it here. Courses like how to design a bridge or a structure. Okay, so the first case is when we determine that the member is in compression, which means that the forces applying on it tend to shorten it. And please consider that it's a coupled force and not a single one, because if it was a single one, the member, would have an acceleration, but it should be static. Okay. In the compression case, we need to know the value of force, because we need to make sure that its value is smaller than a value which is called the critical load. But if it be greater than the critical load, the member would, guess what, would buckle and then fail. This is the value of the critical load for a member with circular cross-section, or a member with the shape of a 10 cylinder. Here K and pi are just constants, and R is the radius of the cross-section, and L is the length of the member, here the red one. Now such a structure should support its weight, and also P, should support some load. For instance, suppose this is a crane and it should support a load up to 20 tons. So the red member also should stand under the loads which it experiences because of the weight of the structure, the crane, also because of the values of load P. So the maximum of the force on it should be always smaller than the critical load. So it would not buckle. But if it be the Fmax be greater than the critical load, that's the problem, and an engineer should take care of it when he or she designs it, and it is before constructing the structure or manufacturing it. But how? You see, here we could not do anything about the Fmax because it depends on the load P, the maximum of load, or the Pmax the structure should support, and it's duty supporting loads. Okay, so we could not reduce Fmax, but we could increase the critical load. So Fmax becomes again smaller than it. Here, K and pi are constants. Also, L, the length of the member, is fixed because its endpoints are fixed. So the only thing we could change here is R, the radius of the cross section. So we should increase it, or we should make the red member thicker. For instance, if Fmax be 10 tons and the critical load be 9 tons, we should increase the critical load to, for instance, 11 tons by increasing its radius. Or, correction here, ton is for mass and not force, and for instance by 10 tons I meant the force of 10 tons, the gravity force of 10 tons, which is 10 tons times 9.8, and it is in newtons. Also, an engineer should calculate the forces on each member, not just the red one, because any of them would buckle if be in compression and the force on it be greater than its critical load. Okay. Now, what if the member be in tension? Why do we need to calculate the value of force in that case?